This is lesson 8.6, changes in dimension. The bell work is to first find the volume of the cube below, which is 4 by 4 by 4. And then number 2, you want to find the volume of a cube whose dimensions have all been enlarged by a scale factor of 2. It says first draw the picture of what it would look like, and then of course find the volume. Remember, scale factor is what we multiply each dimension by, and we have 3 dimensions. Take a moment and do that. Pause the video and then come back to me. All right, I'm going to explain that using this slide here. The first cube, number 1, is here. It's a 4 by 4 by 4 cube, so the volume is just 4 times 4 times 4, which is 64 inches cubed. That's number 1. Now, if we're going to enlarge it by a scale factor of 2, that means every dimension is 2 times larger. So if we're calling this the length, okay, well, it went from 4 to 8 because it's 2 times larger. So every dimension gets multiplied by 2. If that's the length, we'll call this the width, right? The width goes from 4 to 8, just multiply it by 2, and the height also gets multiplied by 2. So it's not just like, we're not going to just multiply the original volume times 2. Let's look and see. Let's do this first. All right, so the volume here of this bigger cube, this is number 2, is 8 times 8 times 8, which is, of course, 512 inches cubed. Now, what does that mean in terms of what we multiply by? Instead of drawing a picture every time, think about what you're multiplying by. We're not just multiplying the original times 2. 64 times 2 does not give us our 512. What we're doing here is multiplying each dimension by 2, and since volume is 3-dimensional, that gives me 1, 2, 3 2's that I'm multiplying by. Here's my original volume, 4 times 4 times 4, and then they broke it down right here, 4 times 4 times 4, times 2 times 2 times 2. Well, that's just 2 to the 3rd power times our original volume. So when you have something 3-dimensional like volume and you're changing it by a scale factor, you're multiplying by that scale factor to the 3rd power, 3 dimensions. And I want you to write this in your notebook. To find the volume of a similar solid, this is where you start right here. Okay, write that down. Pause the video when needed. In words, we multiply the original volume by your factor raised to the 3rd power. And that's, again, because volume has 3 dimensions. And then I wrote it out for you as an equation. The new volume equals the original volume times the factor to the 3rd power. And I'm going to write that like this. So the volume with a subscript of n, meaning the new volume, equals the original volume. I'm going to put a little O here. That's the original volume times the scale factor. I'm just going to call it S to the 3rd power. All right. We're going to be doing the odds together, and then you're going to do the evens on your own. This is a worksheet. If you don't have it already, you can just copy down the problems. All right, we have number 1. We're changing in dimension. So we have candles. The volume of a candle is 8 cubic inches. What is the volume of a similar candle that is larger by a scale factor of 1.5? Remember, when you have whole numbers, it's making it bigger. Actually, I can't say whole numbers. When you have a number bigger than 1, it becomes bigger. If I'm multiplying by a number smaller than 1, it's going to become smaller. So the volume, the new volume, this is our formula that I'm using, the new volume equals the original volume times that scale factor, but not just the scale factor. Since we're using volume, it's the scale factor to the 3rd power. So we don't know the new volume, so that's V of n, or V sub n. V sub O, that's our original volume, well, originally we had 8 cubic inches. So that's 8. And we're going to multiply it times the scale factor here, 1.5. And of course, raise it to the third power. All right, order of operations, which one do we have to do first? That's right, we need to do our exponent first. So 1.5 to the third power. Let's see on my calculator, 1.5, raise it to the third power. I get 3.375. And then multiply that times 8 to get our answer. The new volume is 27, and we're talking about inches, and of course volume is still cubed. All right. We're going to do number 3. So make sure you go to number 3. We have crackers. A box of crackers has a volume of 48 cubic inches. If I highlight or circle something, that's what you should be doing as well. So there's our 48 cubic inches, our original volume. What's the volume of a similar box that is smaller by a scale factor of 2/3? Notice 2/3 is less than 1, so we're getting smaller. All right, so the original volume, let's do this. The new one is going to be the original volume times the scale factor to the third power. Remember, we write down our equations, our formulas, so that we can remember them. All right, our original volume was 48, and our scale factor for our new volume is going to be 2/3. And I'm raising that to the third power because volume is cubed. All right, 2/3, you can just do it on your calculator as 2 divided by 3. And then don't clear it, just raise it to the third power. And then we can round that, that's fine. I'm going to do it 2 ways. I'm going to round, and then I'll show you a different way as well. Let's do that. I have 0.296. Let's just do 0.296. Okay. So let's see, and we'll see if we get different answers. So I'm going to multiply that 296 times that 48. And I get 14.208, so I'm rounding to the nearest tenth, because that's what I'm going to usually do here. 14.2, and we have, this is inches again, so inches cubed. Okay, so that's our answer. For those people that want to see that without the rounding, you would just do, I'm going to do it over here. It would be 48 times 2/3 to the third power. Well, that's 2 to the third power. Let me write it like this, 2 to the third power over 3 to the third power. Let's just do that again here. We have 2 to the third power is 8. 3 to the third power is 27. And then 48 times 8 divided by 27. Or if you use a calculator, or your fraction on your calculator, that works the same. This is just 14.22222. It still rounds to the same thing, 14.2. So this one is just fine for this. All right, we're on number 5. A cone has a volume of 7,560 cubic millimeters. Let's circle that. That's the volume, original volume. What's the volume of a similar cone that is 1/6 the size of this cone? Well, hopefully you know 1/6 looks like this. All right, so the new volume is going to be the original times that scale factor to the third power. And this is my own formula, by the way, that I don't think I've ever seen it written like this, but I like it like this because it's easier for me to show you what we're doing. So the new volume we don't know still, but we know the original volume was 7,560, and the scale factor is just that 1/6, and we're raising it to the third power. All right, let's do this. We need to do the exponent first. So 1/6 to the third power, I'm just going to, on my calculator, 1 divided by 6 equals, don't clear it, just raise that to the third power, and I'm going to estimate here. I'm going to go out a few more decimal places because there's a lot of zeros. So 0.0046. I'm going to stop there. It doesn't really matter where you round. Obviously, I wouldn't want to do it times 0, so just make sure you have something to multiply by. All right, so this is this number, 0.0046 times 7560. I get 34.776. If I round it to the tenths, 34.8. And this is millimeters cubed. And by the way, if you want to, when you get this number here, when you raise it to the third power, you can just use that number. Don't clear your calculator and just multiply that times this original volume. That'll be more accurate. So that's a good idea to do. But this is our answer for this one. Why don't you try pausing and see if you can do number 6. I'll put the answer key online so you can see it. All right, number 7. The volume of a clay sculpture is 540 cubic inches. What is the volume of a similar sculpture that is larger by a factor of 2.5? The new volume is the original volume times the scale factor to the third power. So we've got original volume, 540, times that scale factor of 2.5. Raise 2.5 to the third power. I don't need to round here, it doesn't go out very far for decimals, so this is going to be 540 times 15.625. And last step, multiply that times that original volume. I get the new volume to be 8,437.5 inches cubed. All right. Number 9, 8, and 9 both use that picture there. So we're doing number 9. Find the volume for a rectangular prism that is smaller than the one shown here by a scale factor of 1/10. Well, we need the original volume. So the original volume is this times this times this. So 24 times 8 times 10. So the original volume, I'll call it V sub O, is 1,920 centimeters cubed. Length times width times height. So the new one, that's smaller by a factor of 1/10, is what they're asking. We're going to take the original, multiply it by 1/10 to the third power. All right. Well, the original was 1,920 times that 1/10 to the third power. On my calculator, 1 divided by 10, raise it to the third power. It's pretty small. It's 0.001. And when I multiply that times 1920, I get 1.92, and we have centimeters. Centimeters cubed. Okay. Then we have the hot question. I'm not going to do it for you, but I'm going to let you think about this. A cube has a surface area of 150. We're talking about area now instead of volume. How many dimensions does area have? Area has, well, if we find area as like a length times width, or base times height, how many things are you multiplying? 2 things. Length times width, that's 2 things. So area is 2-dimensional. So if you think about that, you have an original surface area and you want a new surface area that is larger by a scale factor of 2, well, what are we going to raise that to? What power are we going to raise the 2? Think about that. And double check Google Classroom that there's no other assignment.